Welcome back people, I'm Pawan and in this video we are going to learn on the topic of granularity of data items along with multiple granularity locking on the subject database management systems. So let's start. First one, we have an introduction to data granularity. Data granularity refers to the level of detail of precision at which any data is stored, displayed or any used for analysis. Here when in context of databases, it pertains to the extent where the data is divided into various levels. Now, to understand data granularity, it is crucial for database management systems as it directly impacts the efficiency and accuracy of the data retrieval and manipulation. Now, the granularity ranges from fine to coarse, where the fine granularity refers to detailed data elements, while coarse granularity represents higher level of summarized data. Next one is the types of data granularity. We have atomic level, column level and row level. Now we'll go each by each. The atomic level refers to the finest level of detail where the data is stored, providing the most precise and individual piece of information. When compared to the column level, here it involves focusing on specific attribute instead of the whole database. Here it allows for analysis and manipulation of data based on individual columns and rows, providing insights into the characteristics and properties of each attribute. Next one is row level. Here it involves the level of detail at the record of tuple level. It allows for examination and manipulation of whole entire records, enabling comprehensive analysis and processing of data entities as complete units. Next one, we have advantages of using multiple granularity locking. First one is improved concurrency. This allows for finer control over locking mechanisms, enabling concurrent access of the different levels of data, which improves system performance and resource utilization. Next one is reduced deadlocks, where the ability to acquire and release locks at any given time at different levels allows for maintaining data consistency and integrity. It reduces the risk of data corruption and inconsistency. Next one is optimized system throughput. Here the flexibility of multiple granularity locking allows for optimized throughput, and it allows for transactions at data access at different levels simultaneously, which thereby improves overall system efficiency. Next one is so let's see how this works. First one are shared locks. With the transaction, when they need to read the data, it acquires the shared lock on the item, where it allows for other transactions to read the item, but they are not allowed to modify that. Here it ensures the data consistency and concurrency by allowing multiple transactions to access the same data without conflicting with each other. Whereas in exclusive locks, when a transaction requires to write or modify any data, it requires exclusive lock on that particular item. It prevents other transactions from reading or writing when any particular transaction is in process. So here the other transactions have to wait until the lock is released. By doing so, it ensures for changes made by the transaction to be isolated and not affect any other operation. So it preserves the integrity of the data. In the granularity levels, multiple granularity lockings allows for various levels of locking to be applied, such as we have our page, table and row level lockings. Now this flexibility enables for transactions for any specific data that they need, but it reduces the unnecessary blocking and contention, which improves concurrency, allowing for parallel access of different granularity to different granularities, optimizing the performance of multi-user database systems. Next one, we have a comparison of multiple granularity with other locking techniques. First one, multiple granularity locking. It is concurrency control mechanism in a database which allows for flexibility in locking at various levels of data, such as row, tables or databases as a whole. So it enables to lock not only a specific data item which the transaction needs, but also they reduces the contention and increases the overall system performance. It allows for a balanced granularity and performance, making it a preferred choice for a multiple user database. When compared to the traditional locking techniques such as the table level or page level locking, these lack the flexibility of the multiple granularity locking. These lead to unnecessary contention and reduces the concurrency, while the page level locking results in more data locking than necessary, which impacts the overall system performance. So these techniques are less suited for the modern and dynamic databases, which are where the fine-grained approach to locking is very essential. Okay, we have an example of scenario where these lockings are very useful. Now, one example is a university where the student, professors, and administrative staff are trying to access and modify data at various levels, such as when a student tries to register for the course, the system needs to lock on to that specific course entry to prevent any locking conflicts. Whereas, at the same time, the availability of the seats in an entire course needs to be managed, which requires a different level of locking. Similarly, when the professors are trying to make a change in the course levels and the administrative staff are trying to alter the academic calendar. Here, in both cases, they require concurrent access and locking at various different granularity levels. Next one, okay, so we have the challenges in implementing these locking methodologies. First one is concurrency control. So when such locking are introduced, they are effectively controlling the concurrency of transactions. So the system handles requests from multiple users, manages the lock conflicts, and ensures efficient access to shared resources, which in turn becomes a complex task. Next one is deadlocks. Here, the risk of transactions getting stuck in between a deadlock situation increases as it requires careful designing and implementation of a deadlock detection and resolution mechanisms. Next one is performance impact. Introducing multiple locking can allow for significant impact on the performance of any database system. The balancing of a data consistency within minimizing lock contention and overhead requires careful consideration and often involves trade-offs. Next one is complexity of implementation. Now, implementing and maintaining multiple locking mechanisms add for complexity in the overall system, which through understanding of a database schema or transaction patterns involving in choosing the appropriate locking granularity level for different data items. Next one are the best practices for using multiple granularity locking. First one is understanding of locking mechanisms, where it is very crucial for us to thoroughly understand various locks within a database system. This knowledge helps in implementing and managing multiple granularity locking. Next one is effective transaction management. Now, to ensure a proper transaction management, it is very essential for a successful implementation of complex granularity locking, which includes mapping of asset properties, handling rollback, commit operations, and minimizing lock contention. And finally, we have the performance considerations when using the multiple granularity locking. First one is the performance impact. Now, when we implement this in a database system, it is very essential to consider the performance impact. Since the system needs to handle logs at different levels, there can be an increase in contention for resources, which can lead to performance bottlenecks. Next one is resource utilization. Here, the utilization of system resources such as memory and CPU should be carefully monitored. When such lockings are used, more resources are are used when compared to the normal locking mechanisms. For concurrency control, such aspect becomes crucial as the granularity locking directly affects the level of concurrency in the system. So it is very important to balance the need of a transaction isolation of system with its ability to support concurrent operations effectively. We are at the end of our slides. I hope you liked my video and click the like button if you like it. Thank you. Thank you very much.